Okay, before we get started on the training here, I wanted to show you guys something. This is just a bag, and there's nothing in the bag. There's nothing in the bag. Nothing in the bag. All right. And the purpose for this is to point out to you that nothing about electricity is magic. Okay, and the reason that people struggle with it is because they don't understand the trick. And the trick is that there really is no trick. Okay? Because there really is no such thing as magic. It's all illusion. And the biggest illusion that you guys are involved in is believing that you can't do this stuff, which you really can. So, more than anything else, what I want you guys to understand is that nothing that I ever talk about is magic. And if you know how the trick works, then suddenly all the mystery is gone and you're more successful. So more than anything else, what I want you guys to do is understand that this is not magic. It's not impossible to understand. It's actually pretty easy to understand. You just have to convince yourself of that. In the same way that I tell people that it's always something simple. As crazy as it sounds, I have ice in my drink because last night the ice maker in the fridge, in the freezer, whatever, stopped working. And I'm not an ice maker mechanic, but I took it out and took a couple screws out and pulled it off. There's a little circuit board in there with some contacts, and I just started looking, and I just looked and looked and looked and looked and looked. I didn't immediately say, oh, I need a new ice maker, or I need a new card, or I need a new board, or I need a new motor. Okay, that's what mechanics do. Mechanics go to the part, okay, and electricians need to go to the test point, okay? 80% of faults occur in wires. 90% of the time it's at the end of the wire, because that's where the dissimilar metal corrosion occurs. And it's also where the greatest amount of damage and environment and leakage and water and salt and corrosion, blah, 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 shows up at the end, at the terminating points of the wires. So that's the most likely place for things to happen. Well, there are other little things that happen, like arcing and diodes fail and switches corrode and blah, blah, blah. Well, last night I just took the ice maker apart and looked at it really, really, really carefully, because I know that it's always something simple, okay? And you know this, but a lot of people don't remember it, but you know it. It's something simple. It's always something embarrassingly small. So I looked, and there was a burned point in one of the contacts where the heating element was, which is high amperage. Makes sense, right? So I cleaned that and laid some solder in with some wire and built the contact up again. And then it still didn't work, and I took it apart again and looked again, and I happened to notice that there was a set of contact points in there. And I got a good flashlight out, and I saw that they were kind of dark. So I thought, well, what the heck, you know? So I took out an emery board, you know, like the ladies used to file their nails, made out of cardboard. I just cut it and made a really tiny little sliver of emery board, and just went, and just did this for like a minute or 2 minutes, and just did it. Put it back together, and this morning we had ice. Okay, so it's always something simple. So if you're a guy watching this who actually works on equipment, trucks, boats, cars, airplanes, whatever, okay, the most important thing you can do is to stop assuming that it's going to be something terribly complicated, because it's not. It really will not be. And the best way to avoid embarrassment and to be a genius is to know that, because if you go out not realizing it, then you end up feeling stupid when you figure out that it is something simple. But if you go out there knowing it's going to be something simple, when that's what it turns out to be, you're a genius. Amazing. You just go from putz to genius in like one thought. It's always something simple, okay? So it's not magic. It's really pretty straightforward. And I'm about to do rheostats and potentiometers for you, and you'll see very quickly that if you just pay attention to the small things, then suddenly the big things make sense. Can you see me now? Okay, well, first of all, just so you know, the whole idea here is that when you watch these videos, the light bulb goes on, because I want you to understand what's actually happening. So what I'm about to do involves several things. It involves language, schematics, basic circuit principles, and some other things. And I'll show you some meter reading and everything, but we're talking about rheostats and potentiometers. And with luck, when I'm done, you'll better understand them. Man, I am not even remotely photogenic. Okay, so see if I can do this and have it make sense. First of all, rheostat and potentiometer. This is exactly how I do it in class on the whiteboard. Okay, rheostat and potentiometer. Rheostat and potentiometer. These are all Latin words. Okay, meter you know, because it means to measure. Tachometer, speedometer, meter. Stat is a word you know. It means static or not moving. Okay, now if you've worked with an old fart, you may have heard electricity called potentio, or potential, because the word potent, P-O-T-E-N-T, potent means strong. Okay, well, that's another word for voltage. So a potentiometer literally measures voltage. Okay, rheostat. It's the exact same thing I do in class. If any of you guys are dealing with a 0 to 2-year-old, then you know this word. Okay? And don't be offended by it, because you've said the word and you know the word. And the word is diarrhea. Rhea. Okay? Rhea means flow. And in electricity, flow is amps. Okay? This is also why the Spanish word or the Latin word for river is rio, because rio means to flow, and rivers flow. Okay. All right, so the first thing is the language. The language is critical for you to understand, because the language tells you what the thing does, okay? Starting over here, because it's just a little easier to understand, a potentiometer literally measures voltage, okay? Quick point, a potentiometer will always be a sensor, okay? The rheostat is the only one that can be called a variable resistor. Okay, so a variable resistor will always be a rheostat, and a potentiometer will always be a sensor. Okay, so you need to remember that. If you need to pause the video and write this down, then pause the video and write this down. So the first thing is language. We use the words that we use because they mean something. All right, this is not just a made-up word, and that's not just a made-up word. That's a legitimate word that means something, and both of these words tell you that these devices are different. This one involves flow. This one involves voltage. Well, voltage and flow are not the same, and don't call them juice. Drive me crazy calling things juice. You know, part of a balanced breakfast, but it's not part of electricity. Juice. Juice, I got juice. All right, fine, whatever. Okay, so we got a rheostat, we got a potentiometer, and the words actually tell you what they do. Static flow, meaning that we set it and the flow remains constant. Well, in your dad's or uncle's or grandfather's 69 pickup truck, the rheostat that controlled the dash lights was a thing that went zoop, 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 and you heard it because there was a spring in there. There was literally a spring resistor. Okay? Well, a potentiometer is smaller because it doesn't have to carry huge amperage. This thing could be big. This thing could be huge because it has to carry big amps, okay? But this is small, or should I write it? I'll write it here. Small because it has virtually no amps. Very few, okay? So, my table's kind of flopping around here. Okay, so, first lesson, language. Language, rheostat, flow stable, potentiometer, voltage measure. Always a variable resistor, only a variable resistor, and a potentiometer will always be a sensor. Okay, so now's a good time to pause if you want to write this stuff down, because I'm going to keep moving, because I tend to make long videos. All right, well, let's look at the schematic symbols. First of all, the schematic symbol for a rheostat, the basic symbol is this, which is why it's easy to confuse with the basic symbol of a potentiometer, which looks like this. Now, if you look carefully, you'll notice something very, very, very different, and that difference is critical. The first and most critical difference between these two in real life and on schematic, okay? Sometimes you'll see it like this. Sometimes you'll see it other ways. That's a variable resistor. Maybe it'll be this. But still only 2 wires. So the first thing about the rheostat is it has 2 wires. Oops, 2 wires. 2 wires. On the other hand, the potentiometer can have, or excuse me, will have, no, that's wrong, I said can, it will have 3 wires. That was a mistake. No, potentiometer will have 3 wires. All right, so now let's look at these. Just look at the symbols and think about them for a minute. Okay? Oh, and by the way, this is very often drawn like this, depending upon your manufacturer. Notice the difference, there's no wire on that, so there's 2 there and there's 3 there, okay? So it just depends upon your manufacturer. But if you can keep in mind the difference between the 2 of them as being largely the number of wires that each of them has, then you'll know the difference, okay? All right, so they're different. Well, how is that different? Well, in this case, if we have a battery and we have a rheostat, then because it's a variable resistor, then as we move the variable resistor from place to place to place, then what we end up with is a changing resistance, which is why it's called a variable resistor. Okay, all right, get some other colors here. That'll work. Use the meter, Luke, use the meter. Okay, all right, so here you go. We can move this left and right, and this is a resistor, right? So if we make the resistor shorter, the formula is volts over ohms equals amps. So if we have shorter or less resistance, we have more amps and the light gets brighter. If we go to the right, then the resistor gets longer, there's more resistance, and therefore more resistance means less amps, and the light gets dim. So this is a standard rheostat. That's it, okay? In some cases, this will be used for temperature sensor. This is also used for fuel level sender, because you'll have the fuel level sender here with the terminal there, and then you'll have this little thingamabobber in there, and there's a resistor in there right there, and then this float comes down and there's a float right there, and as this float moves, the resistance changes. And if we make this a motor, which is what a meter is, then this motor will move, and if you have empty here and full here, you get a fuel level, and it's all rheostat. So you can actually take a resistor from Radio Shack of the right size, stick it right here in place of the fuel level sensor, and you'll get a fuel reading. Okay.
One more thing. Every one of these gauges has a certain amount of resistance required at the sender to read a certain thing. So what I've got here is I've got these resistors that I put together according to the chart in the manual, and each of these resistors here, each of these resistors is going to give me a certain reading. This one will give me empty, this will give me full, this gives me 3/4, half, and 1/4. So let's start with empty, okay? Empty is 240 ohms according to the chart. So if I put in the 240, notice the gauge goes to empty. Okay? If I then put in the 1/4, which is about 150 ohms, notice that the gauge goes to 1/4. If I put in 100, I get a half. And if I put in 60, I get 3/4. And last but not least, if I put in 33, I get full. The importance of doing the test this way somehow is that you're getting a calibrated answer that isn't just watching the needle move. You're forcing the system to work according to the specifications that it was built to.
This is pretty basic. This is fairly straightforward. There's not a lot to this. And the key again is to remember that there are only 2 circuits, or 2 wires, all right? So when you look at a schematic, if you see anything that kind of looks like this, and if you have my book, it's in the back of the book, there's like 7 or 8 pages of schematic symbols. You can also find them on your manufacturer's drawings, but I guarantee you there's at least a 1 out of 2 chance that they labeled them wrong. But anyway, it's 2 wires, and that's the key. 2 wires. 2 wires, okay? Well, the rheostat's got 3, and it works differently. And if you look at this like a mechanic, if you look at this like someone who's got some common sense, which all of you do, then you'll notice that this resistance doesn't change between 1 and 3. And just for those of you who work on vehicles, 5K ohms is pretty typical, okay? Because that works really well with 12 volts. So 5K ohms is a good number. So if you have a potentiometer, there's a very good chance it's 5K ohms, and that doesn't matter. That doesn't change anything. It doesn't, I mean, it could be 10K, it could be 2K, it works the same way. But for our world, 12 and 24, you'll usually see 5 and 10K. Okay, that's 5,000, right? 5,000. Meter reading, right? 5,000, 5K. Okay, so if this is 5K from here to here, then what's going on here? Well, this is the wiper, and the wiper moves, okay? And the way this works is that we hook it up to something, usually an ECM, and this is just a light bulb. It's just it's a resistor, nothing else to it. So this is going to be plus 8 volts, let's say, 8 volt sensor, and then this is ground. So in effect, we're just turning this resistor on. It's just on. It's just on. It's getting hot, but not hot, just it's on. Well, it's exposed on the inside, and if we put a voltmeter here, this is always going to be the signal in the middle. Always number 2. Always number 2. 1 and 3 may flip, but 2 will always be the signal, okay? So when you look at the potentiometer, generally they physically look like this, and they have a little terminal there, a little terminal there, a little terminal there, and a little screw here, a little slot right there usually, and a nut, right? And inside there's actually a resistor, and that resistor literally goes around like that. and then the number 2 terminal goes into the center and then comes out with an arrow. And this, okay, so we put voltage here, put ground there. Wait a minute, that's a 3. I'm sorry. Dumbass move. Okay, 1, 2, 3. 2 is always a signal. Okay, just remember that. 2 is a signal. Okay. Okay, so let's look at how this works then. All right, so here's what we do. We take the 8 volts, which is right here. We'll say that the 8 volts is right there. And then we take ground, which we'll say is right here. So that's 0 volts, because everything on ground should be 0 after the load. And then what happens is the voltage drops over the distance. And that's what it does. Okay, that's how it works. And hopefully you can see that. Let me make a little. Okay. All right, now that's the best graphic illustration I can give you because it starts at 8 and then it goes to 0. That's called voltage drop. The resistor is getting hot and dropping the 8 volts. So that means that if the wiper is dead center, there'll be 2,500 ohms here and 2,500 ohms here, right? 25 plus 25 is 50. It starts at 8, it ends up at 0, which means in the dead center I have 4 volts. And this device is giving me a measured voltage. And that's it. That's how it works. That's all it is. That's all it does. Okay? So as this is a throttle, if this is a throttle position sensor, or if this is a position sensor on a bucket, or a position sensor on a lift truck, or a position sensor somewhere, as this needle moves, right? As this thing moves around to measure the position, then the wiper will be reading a different voltage every time. And usually it's a half a volt here and a half a volt there, so the range would be like 0.5 to 7.5 or something like that. It's just, it depends on the system, but they all work exactly the same way. I mean, so this works this way, this works this way, but they're different. And I keep stressing that because they're not the same thing. So when you look at the schematic, you can't just go, oh, variable resistor. Oh, if it's got 3 wires, it's a sensor. If it's got 2 wires, it's a variable resistor. It's important. Okay, so what do we have here for potential problems? Well, it's very simple because it's corrosion, and corrosion is your biggest killer in any of these systems, but this one is particularly susceptible to corrosion because let's say that we have a connector here, and let's say that we've got some green crap, and let's say that there's resistance there, and let's say that that resistor sucks up 2 volts. Why? Because resistors suck up volts. If current's flowing through a resistor, the resistor gets hot and voltage goes away. Voltage drop. That's called a voltage drop. Which means if I'm starting at 8 here, I go 8, 8, 8, 8, 8, 8, 8, 8, 8, boom, 6, 6, 6, 6, 6, 6, 6. So I'm not 8 anymore, I'm 6. And 6 is here. Okay? Or yeah, somewhere around there. 4 or 6, yeah, that's right. So then we're not dropping from 8 to 0, we're dropping from 4 or 6 to 0, excuse me. Well, what that means now is in the middle, we're not reading 4 anymore, we're reading what? I'm listening. We read 3. Okay? And most importantly, what you have to understand is that if you have a computerized system, you get no fault code. Why? Well, because 3 is still within the acceptable range, and therefore you get a low power complaint, where you get an incorrect position, or you just have weirdness going on. And the key to being successful with any of these systems is to always suspect the wires. Wires are the fault 80%. So that means if you walk out to a truck okay, and you stand there and you look at the truck and you scream It's a wire. And you haven't even done anything yet, you'll be right 80% of the time. So, lots of stuff going on here. Let's review. Okay, first of all, rheostat. Rheo means flow. Diarrhea. Stat means not moving, static. Rheostat, flow stable, flow not moving. This is a flow control device. Can be high amperage, but it's the only one that can be called a variable resistor. All right. Potentiometer. Potentiometer. Voltage measures voltage. Okay? It must be and will always be a sensor. It's small and there's not a lot of amperage flowing through it. Okay? So they're different in a big way, even though the differences look small. 2 terminals or 2 wires, 3 terminals and 3 wires. Okay? There's a wiper inside there, there's a wiper inside there, there's a resistor inside there, there's a resistor inside there. So people want to say, oh, they're the same thing. Nope, they're not the same thing. And I don't care what the manufacturer calls them. You need to know deep down inside that a rheostat is a rheostat and a potentiometer is a potentiometer. They're different. They're not the same thing. And wires will be the problem 80% of the time. And if you focus on changing this part, you probably will fail. If you focus on the wiring to the part, then you probably won't fail. Okay? So this is how they work. And next page will be how to understand them and test them and what your expectations should be. So we'll break away and then I'll come back and I'll have a new sheet of paper and then we'll just keep moving from there.